In this video, we are going to talk about isomerism in coordination compounds. We studied what is isomerism, what are the different types of isomerism. We can classify isomerism mainly into two, structural isomerism and stereoisomerism. Coordination compounds are showing both structural and stereoisomerism. What do you mean by isomerism and isomers? The compounds having same molecular formula but different spatial arrangement or structural arrangement is known as isomers, and this phenomenon is known as isomerism. Isomers are two or more compounds having same chemical formula but different arrangement of atoms. Maybe structural variation or spatial variation. So that is known as isomers. Isomerism is of two types, structural isomerism and stereoisomerism. In the case of coordination compound, structural isomerism is of different type, ionization isomerism, hydrate isomerism, linkage isomerism, and coordination isomerism. Stereoisomerism is also of two types, geometrical isomerism and optical isomerism. So isomerism is of two types, structural isomerism and stereoisomerism. Structural isomerism of four types, ionization isomerism, hydrate isomerism, linkage isomerism and coordination isomerism. Stereoisomerism of two types, geometrical isomerism and optical isomerism. First we can see structural isomerism in detail. Structural isomerism occurs when there is a difference in the structure of coordination compound. They are having same formula, but there is a difference in the structure of the coordination compound. In that, first we can move to ionization isomerism. From the term itself, ionization isomerism. When the compound is undergoing ionization, there is a difference in the product formed. Different ions are getting ionized even though that two compounds are having same formula. Difference arises from the position of the group within or outside the coordination sphere. These isomers will give different ions in solution. Example: CO NH3 5 times Br square bracket SO4. SO4 2 minus ion is counter ion in this case. Name of this compound is pentaamine bromido cobalt 3 sulfate. It is having a violet color. When it is undergoing ionization, it will give us a violet color. But another compound which is having red color and the formula is CO NH3 5 times SO4. Counter ion present here is Br. When we are comparing these two, we can say both contain cobalt, both contain NH3 5 times, both are having Br, both are having SO4 2 minus ions. But the only difference is that the counter ion in this case is SO4 2 minus and the counter ion in this case is Br minus. We know that it is the only part which is getting ionized. So when this compound is getting ionized, SO4 2 minus will be the ion present. When this compound is undergoing ionization, Br minus is the ion present. So, the ion which get ionized is different even though they are having same formula. Difference arises from the position of group within or outside the coordination sphere or square bracket. These isomers will give different ions in solution. Or ionization isomerism arises when the coordination compounds with same molecular formula give different ions in solution. Or ionization isomerism arises when the coordination compounds with same molecular formula give different ions in solution. They are giving different ions in solution. Second one is hydrate or solvate isomerism. This isomerism arises due to the difference in the number of water molecule present inside the coordination sphere. Two compounds having same formula but difference in the number of water molecule present in the coordination sphere. We can take one example. CrH2O 6 times Cl3, which is violet in color. CrH2O 5 times Cl, outside the square bracket, Cl2H2O, which is grey in color. Grey-green in color. So what is the difference? Both contain 6 water molecules. Both contain 3 Cl. Both contain chromium. But the number of water molecule present inside the square bracket is different. In this case it is 6. But in the second case it is only 5. Hydrate or solvate isomerism arises due to the different number of water molecule present in the coordination sphere. Now the third one, linkage isomerism. Linkage, difference in the linkaging atom. We know that there are some ligands which are ambidentate in nature. It can ligate through 2 different atoms, one at a time. So, this isomerism is shown by compounds having ambidentate ligands. It arises in a coordination compound containing ambidentate ligand. Example, CONH3 5 times NO2 Cl2, which is yellow in color. CONH3 5 times ONO Cl2, which is red in color. The only difference here is, in the first case, it is ligating through nitrogen, but in the second case, it is ligating through oxygen. So, difference in the ligating atom of the ligand. And this is shown only by compounds having ambidentate ligand. Now the fourth structural isomer, coordinate isomers or coordinate isomerism. It arises from the interchange of ligands between complex cation and complex anion. That is, between the coordination spheres. You can see this example. In the first example, CrNH3 6 times, COCN 6 times. In the second compound, CONH3 6 times, CrCN 6 times. This is an example for a compound with both cationic and anionic part is complex. And what happened here? Interchange of ligands between the coordination sphere. This type of compounds will show coordinate isomerism. It arises from the interchange of ligands between complex cation and complex anion, or in between the coordination sphere in a compound. Name of this first compound is hexaamine chromium 3 hexacyanidocobaltate 3. Second one is hexaamine cobalt 3 hexacyanidochromate 3. So we can conclude that coordination compounds are showing 4 types of structural isomerism: ionization isomerism, hydrate isomerism, linkage isomerism, and coordination isomerism.